So this episode is going to be dealing with some of the calculus features of the calculator. And so when you're dealing with calculus, you usually have functions that you're dealing with. So rather than have to type in the function every time, what I've done is I've gone to the graphing page and I've just entered a couple of functions. You see that I have this function, the absolute value of x over x. Take a quick look at what that looks like. We've seen that before. Comes in. It's a nice limits problem. We'll use it for a limit command, and I've also used 2 times the sine of 3x. We can see what that looks like. It's no surprise there. Looks pretty much what I thought it would. And so I'm going to show you how to deal with the derivatives and with the integrals for this function, and then the limits. I'll take a look at the function beneath it, this function here, and then we'll do a summation problem or two. To start with, though, I just want to show you how to use the solve and the solve systems with using constraints, because this F1 is periodic. So if I solve generally, I'm going to get infinitely many solutions. It's going to show as a general form, and I want to see specific solutions. So we want to be able to use constraints. So I'm going to go back to the calculate page, and I'm going to go to solve. If I have a keypad, I can just type solve. It's found in the algebra menu, and I'm going to add the parentheses, and I want to solve where my function, the 2 times the sine of 3x is equal to 1. But I'm not going to type 2 times the sine of 3x because I have it already here, and so it's stored in my vars page. So I go to vars, and you see I have f1 and f2, my 2 functions that I've defined. I want this function, f of x, f1 of x, and I want that to be equal to, let's just say equal to 1. And I'm going to solve it in terms of x, and when I hit enter here, you're going to see it looks a little odd. This is the general solution to this particular equation. I only want specific solutions, so to get constraints, I can go back and copy that over again, and outside the parentheses, you see I'm outside the parentheses, I'm going to add right on this menu here with the inequality signs, I'm going to add this vertical line. It means such that. So I want to solve this such that 0 is less than or equal to, so I go back to my inequalities, less than or equal to x, which is less than, let's suppose I want it to be less than pi. And I can just type pi in, or I can find it right over here on this button. So now I'm only going to find those solutions that are between 0 and pi, rather than the general solution. When I hit enter, and you can see that I get pi over 18, 5 pi over 18, and so on. If I wanted to know what those values were as a decimal, I could just do this and then hit the approximation sign, and you're going to see that I see those same values as decimals. Nice to be able to use constraints. Solving a system, very similar. I come to the menu, and it's under algebra, and down here a system of equations. These aren't linear, so I don't want the bottom one, I want this one. And I have 2 variables, 2 equations. I have 2 variables, and my first equation is y equals f1 of x, and my second equation, y equals, let's say, f2 of x. I'm going to find where these 2 things are equal to each other. And again, this is periodic, so it's going to give me infinitely many. And you see that I get a similar thing. It goes off the screen. I could scroll over and see, but I only want, let's say in this one, 0 to pi over 2. So I can come back here and add my such that 0 And on the keypad, I can do this as well. I could do it on my calculator pad, but I can just type less than or equal to x, which is less than pi over 2. And now I'm going to see the solutions that only come within the window 0 to pi over 2, pi over 18 for x, y is equal to 1, and 5 pi over 18, y is equal to 1. So constraints are nice to deal with, especially when you're dealing with equations that have infinitely many solutions. Okay, now we're going to go on to finding the derivative. We'll work with the 2 sine 3x. So the derivative is under the menu and calculus, and I'm going to find the derivative with respect to x of that f1 that I'm working with. And so f1 of x, find the derivative of 2 sine 3x, and that's going to be 6 cosine 3x. If I wanted to find the derivative at a point, it's a similar process, but I'm going to have to enter some more information. So that's going to be at the menu, calculus, and you see this derivative at a point. Let's suppose I want to know what the derivative value is at pi over 3. So I'll hit derivative at a point. Now it's going to prompt me for some things. I have x, which I want, and I want to find the derivative at pi over 3. So it's going to add that x is equal to pi over 3, and you see it has that little such that. So I want this to be f1 of x, and I just hit enter, and there's my derivative value. Now I want to say something about the AP exam. When you have a problem that is a calculator problem, you are allowed to use your calculator to do this bottom exercise, but you are not allowed to use your calculator to get a derivative. So be mindful of that. When you're doing your homework, that's fine, but make sure you can find the derivatives by hand and not using the calculator. When you're finding at a point, you're okay to use your calculator. Let's suppose we wanted to do the integral of this function, the indefinite integral. I go to menu, calculus, integral, and you see I have options for making it a definite integral, but I don't need to use them if I just want the indefinite. And I'll do this at f1 of x dx, hit enter, and there's the integral, the indefinite integral. Don't forget, it doesn't include the plus c. Don't forget that on your answer. And if I wanted a definite integral, I can come back and choose the integral. I'm just going to do from 0, let's say, to pi over 6. Make something up here, go to pi divided by 6. And I'm doing that of f1 of x dx, and hit enter. And boom, there I see my result, 2/3. Again, on the AP exam, you're allowed to use your calculator to do a definite integral and go straight to your answer without showing any work. You are not allowed to do an indefinite integral. Make sure that you are able to do these by hand whenever you're doing indefinite integrals. And don't forget about the plus c. Okay, we're going to switch to the second function, this function that looks like this. The absolute value of x over x, and I'm going to be talking about the limit. I see that the limit anywhere here, the limit is going to be 1. Anywhere over here, the limit is going to be -1. And if we recall, the limit as I approach 0 should be does not exist because it's not approaching the same thing. Let's just see. We'll verify how that works. If I'm approaching, x is approaching a positive number, it should be 1, negative number, -1, and 0. It should be does not exist. So let's go back to here. We're going to be working with f2 now. Limit falls under calculus, and that's the limit. And it allows me to say, let's say x is approaching 5. Well, I know that I'm working with f2 of x, and I'm guessing that my answer should be a 1 because everything approaches 1 to the right of 0. So when I enter that, I get a 1. If I was approaching a negative number, I should get a negative 1. If I was approaching 0, let's just confirm what we would get if we were approaching 0. I would expect to get, I'm going to just scroll over and approach 0. I would expect to get does not exist because it's coming to two different numbers. When I hit enter, sure enough, I get undefined. However, the limit feature also allows me to do one-sided limits. So if I come back to the menu and I go to calculus limit and I want x approaching 0 and I want it to be coming from the right, I just put that little plus sign up there and I do F1, F2 of x, hit enter, and now I should see a 1 pop up, and I sure enough see a 1 pop up. So you can do one-sided limits, you can do two-sided limits. Finally, summation. Summation's pretty easy. This is a BC, primarily a BC issue, but in case you ever need to do summations, that also happens in the calculus page. So if I go to calculus, I see the sum, and it gives me the big summation notation. Let's just make a problem up. I'm going to do n goes from 1 to 10 of 1 over, remember n is now my variable, so I need to be working with n, so let's do 1 over n squared. And I can hit enter and just see what that is. That's not a very nice number. I might want to see that as a decimal. All I need to do is hit it again and I can see it as a decimal. One of the other things in BC that we're often thinking about is we're thinking about infinite limits. So my n is going to go from 1 to infinity, and I have this infinity button right on the pi page, and I can see what that infinite limit is. Pi squared over 6 if I wanted to see it as a decimal. I can see that too. So there's some main calculus functions that you're going to be wanting to do. Don't forget you can enter your function into the graph. You don't care about the graph necessarily, but you can just refer to it on the function now in the var page. Okay, that's about it.